Hi, my name is Gabe. For this problem, we're asked to solve x cubed plus 512 equals 0. Now, you may be tempted to subtract 512 from both sides of the equation and then take cube roots to obtain the solution x equals -8. But what we know is by the fundamental theorem of algebra, since we're working with a cubic, that we should have three solutions, and we want to be sure that -8 isn't our only solution. So what we want to notice is that x cubed plus 512 resembles the sum of cubes. So let's recall that if we have the sum of cubes, u cubed plus v cubed, we know that this factors into u plus v times u squared minus uv plus v squared. Now, in coming back to our problem, we can write x cubed plus 512 as x cubed plus the cube root of 512 quantity cubed. And since our original equation was equal to 0, this is equal to 0. So from here, what we'll want to notice is that the cube root of 512 is 8, leaving us with the equation x cubed plus 8 cubed equals 0. So here, we can go ahead and use the sum of cubes formula with u is equal to x and v is equal to 8. So this factors into x plus 8 times x squared minus 8x plus 64. And this is equal to 0. Now, since we have two factors and it's equal to 0, we can use the zero factor property, which tells us that if we want to find the solutions to this equation, we can set x plus 8 equal to 0 and solve for x by subtracting 8 from both sides of the equation. And we can set x squared minus 8x plus 64 equal to 0. Now, to solve this quadratic equation, we will use the quadratic formula. Now let's recall what the quadratic formula says. It says that if we have a quadratic equation, ax squared plus bx plus c equals 0, then x is equal to -b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. Now coming back to our problem, we have a is equal to 1, b is equal to -8, and c is equal to 64. So when substituting into the quadratic formula, we have x is equal to a -8, which is just 8, plus or minus the square root of -8 squared, or 64, minus 4 times 1 times 64, and this is all divided by 2 times 1, or just 2. So simplifying, we get x is equal to 8 plus or minus the square root of -192, all divided by 2. So here, we'll want to note that the square root of -192 is equal to 8 times the square root of 3 times I. So our answer simplifies to 8 plus or minus 8 times the square root of 3i, all divided by 2. And finally, this simplifies to 4 plus or minus 4 times the square root of 3i. Now we have three solutions. X equals -8, x equals 4 plus 4 times the square root of 3i, and x equals 4 minus 4 times the square root of 3i. And now we must check our solutions and make sure that they satisfy our equation. Doing this is an important step of solving this equation because we want to make sure that as we went through solving the equation, we didn't introduce any extraneous solutions. So we want to check if x equals -8 satisfies the equation. So we substitute -8 in for x, leaving us with -8 cubed plus 512, and we want to know, is this equal to 0? Well, -8 cubed is -512, so -512 plus 512 is equal to 0, so -8 is one of the solutions to the equation. So for our complex solutions, x equals 4 plus 4 times the square root of 3i, and x equals 4 minus 4 times the square root of 3i, we'll use the binomial cubed formulas. So substituting in 4 plus 4 times the square root of 3i into the equation, we have 4 plus 4 times the square root of 3i, quantity cubed, plus 512, and we want to know, is this equal to 0? Well, when we use the binomial cubed formula, we end up with this equation here. 4 cubed plus 3 times 4 squared times 4 times the square root of 3i, plus 3 times 4 times the quantity, 4 times the square root of 3i squared, plus 4 times the square root of 3i, quantity cubed, plus 512, and we want to know, is this equal to 0? Well, here, we'll use the fact that I squared is -1, and I cubed is -I. So the equation reduces to -512 plus 512, and we want to know, is this equal to 0? Well, yes it is. So x equals 4 plus 4 times the square root of 3i is a solution to our original equation. And checking that x equals 4 minus 4 times the square root of 3i is similar to checking x equals 4 plus 4 times the square root of 3i. We go ahead and we use our binomial cubed formula and write out 4 cubed minus 3 times 4 squared times 4 times the square root of 3i plus 3 times 4 times the quantity 4 square root of 3i squared minus the quantity 4 times the square root of 3i cubed plus 512, and we want to know, is this equal to 0? And again, we'll use the fact that I squared is -1 and I cubed is -I. So the left-hand side of our equation reduces to -512 plus 512, which we know is equal to 0. So 4 minus 4 times the square root of 3i is also a solution to our equation. Thus, the three solutions to our equation are x equals -8, x equals 4 plus 4 times the square root of 3i, and x equals 4 minus 4 times the square root of 3i. Thank you.